Section 7.3 is logarithmic functions as inverses. Our goal is to graph logarithmic functions showing intercepts and end behavior. On page 525, we have many even numbers can be written as power functions with base 2. In this lesson, you will find ways to express all numbers as powers of a common base. The exponential function y equals b to the x power is 1 to 1, so its inverse x equals b to the y power is a function. To express y as a function of x, for the inverse, write y equals log base b of x. A logarithm base b of a positive number x satisfies the following definition. For b greater than 0 and b not equal to 1, log base b of x equals y if and only if b to the y power equals x. You can read this as log base b of x. In other words, the logarithm y is the exponent to which b must be raised to get x. The exponent y in the expression b to the y power is the logarithm in the equation log base b of x equals y. The base b in b to the y power and the base b in log base b of x are the same. In both, b can't be 1 and b is greater than 0. Since b cannot equal 1 and b is greater than 0, it follows that b to the y power is greater than 0. Since b to the y power equals x, then x is greater than 0, so log base b of x is defined only for x greater than 0. Since y equals b to the x and y equals log base b of x are inverse functions, their compositions map a number a to itself. In other words, b to the log base b of a power equals a for a greater than 0, and log base b of b to the a power equals a for all a. On page 526, we have you can use the definition of a logarithm to write exponential equations in logarithmic form. Example 1 says, what is the logarithmic form of the equation 100 equals 10 squared for part A and 81 equals 3 to the 4th power for part B? I've added if x equals b to the y power, then log base b of x equals y from the previous slide. For part A, 100 is x, 10 is the base b, and y is 2. This gives us log base 10 of 100 equals 2. For part B, we have x is 81, 3 is our base, and y equals 4. So we can rewrite this as log base 3 of 81 equals 4. The work for this problem is written out on the next 2 slides. And now I would like you to try number 1, write each equation in logarithmic form. 1/3 to the 3rd power equals 1 over 27.